Assalamualaikum and salam sejahtera. Hi, I'm Madam Shafaz. Today I'm going to share with all of you how we solve these PSPM questions. So firstly, when you got the questions, you have to read the question, go through the question carefully. Once you read the question, what you need to do is you have to highlight the important informations given. If you can see here, I have highlighted the keywords given in the questions. So next step, I'm going to list down the informations given, the keywords that I have highlighted. Okay, we list first. I have length of the conducted rod. We focus on 1A first, okay? 1.2 meter. Next, we are given B, magnetic field, which is 1.25 Tesla. And then the rod is pulled to the right with velocity V equal to 2 ms to power of -1. And you are given the resistance equal to 6 ohm. So to answer this question, the idea is if the question asks you the first one, the induced current in the rod, means we need to find the I induced. Okay, we need to find the I induced. And related to this question, the formula of induced current, we need to relate with the induced EMF. Okay, so the induced formula, I'm focused now question number 1. The induced EMF formula is equal to BLV sine theta. So here your equation number 1. Okay, and then since the question asks you I induced, you must know that this induced EMF we can relate back with the Ohm's law. Hopefully still remember Ohm's law, V equal to IR. Okay, but now the symbol V we have changed to induced EMF, and what I can write here is induced EMF equal to I induced times with the R, and this I just write BLV sine theta. Okay, so actually no need to have first equation here. Okay, so what we are going to do is we need to make it our I induced as subject of the equation. So I induced is equal to B, we have, what is our B? 2.5. Okay, our length is 1.2. The velocity is 2. And sine theta here, what is my sine theta? The keywords here, perpendicular to the plane. Alright, so our sine theta is 90 degree. Okay, 90 degree. And the resistance here is 6 ohm. So please press your calculator. Your I induced, supposedly you got 1 ampere. Okay, now we're going to proceed the next question number 1A2. This question asks us to determine the magnitude and directions of force required to keep the rod moving to the right at constant velocity 2 ms to power of -1. To answer this question, we need to use equation F equal to ILB sine theta. So theta here is angle between vector B and vector V. So it should be theta 90 degree for this situation. And we start to calculate now. I is we got from previous question 1 ampere. Length we have 1.2. B we have 2.5. Sine 90 degree. So we press our calculator and the answer should be 3 Newton. Okay, next question. In the same question actually, we need to determine the directions of force. So the directions of force should be to the left. Direction of force is to the left. Just state the answer like that, to the left. But if the question asks you to explain, so how we are going to explain? Now we try to understand why the directions of force is to the left. When the rod is moving to the right in the regions of uniform magnetic field, there is cutting of magnetic flux. Therefore, the induced EMF will produce. The induced EMF will produce the induced current. When the induced current flow in the rod will experience magnetic force. Since the magnetic force produced due to the induced current, which direction always oppose the change that producing it, as a result, the directions of magnetic force must oppose the motions of the rod and directed to the left. Okay, now we are going to proceed. The next one, questions is 1B1. So I have list all the information given. I have list down here the current, 5 ampere and 400 turns, length 30 times 10 to the power of negative 2 meter. The area is 2.00 times 10 to the power of negative 4 meter square. So the question asks the inductance of the solenoid. So we need to use the formula of inductance, which is specific for solenoid. So the equation is L solenoid equal to mu naught N square A over length. So we need to substitute what is our mu naught. Don't worry, this mu naught you can have in your list of constant. It will be given in your final exam. Refer to the front page of your PSPM paper. So it's a 4 pi times 10 to the power of negative 2. The N here is 400 turns square. The area given here is 2.00 times 10 to the power of negative 4, and the length is 30 times 10 to the power of negative 2. So when you calculate it, the answer should be 1.34 times 10 to the power of negative 4 Henry. Okay, now we are going to proceed the next question, number 1B2. The question asks us about the energy stored. So we need to calculate the energy stored in the solenoid. So I'm referring to number 2. To calculate the energy stored, we need to use formula U equal to half Li square. We have here half the inductance we have calculated in previous question. So the answer is just now 1.34 times 10 to the power of negative 4 Henry. And the I given is 5 ampere square. So I press my calculator and you need to press yours too. The answer should be 1.68 times 10 to the power of negative 3 joule, because the question asks about energy. The units for energy is joule. Then we proceed with number 3. The question asks us to calculate the induced EMF in the solenoid. Actually, if you understand the concept of this question, there is no changes of magnetic flux produced in these questions. Therefore, if we base on the concepts of Faraday's law, induced EMF will produce if there is changes of magnetic flux over dt. Since there is no change in magnetic flux, or we say magnetic field, okay, magnetic flux, therefore induced EMF is equal to 0 volt. Right, so that's the answer. You must know the concept. No changes of magnetic flux means there is no induced EMF produced. Okay, now we are going to answer our last question for 1B, which is 1B4 now. So calculate the induced EMF if the current in the solenoid decreases uniformly to 0 in 0.2 seconds. So if you read this question, actually this question is about self-inductance, because the induced EMF produced due to the changes of current in the same solenoid. So to calculate the induced EMF, we need to use formula regarding to self-inductance. So induced EMF equal to negative L di over dt. So di here means I final minus I initial. So for this question, I initial given, sorry, here I'm referring to I final. I final state here is 0. I initial given is 5.0 ampere, and the dt here is means T final minus with T initial. So our T initial is 0. Our T final is 0.2 seconds. The time taken for the changes from 5 ampere to 0 ampere. So now we have all the value. We can calculate and substitute it in this equation actually. So I write again, this is the equation that we are going to use. Induced EMF negative L di over dt. So negative L, the value of L I got in previous calculation, 1.34 times 10 to power of negative 4. di here we have I final minus I initial, so 0 minus 5 divided by 0.2 minus with 0 is actually 0.2. So when you press your calculator, you will got the answers is 3.35 times 10 to power of negative 3 volt. So this is the EMF that produced due to the changes of current.